Good evening, everybody. Welcome to our first workshop of our workshop series this spring. This one is called 3D Printing 101. I'm going to basically explain to you guys the way to get started with 3D printing and what it is. So this is going to be a very beginner level course. So the scope that we'll be discussing is only a specific type of 3D printing called FDM printing with thermoplastics. FDM is fused deposition modeling. And for those of you who are attending live, you can ask questions in the live Q&A, and I'll see them and I'll be able to answer those as you submit them. So 3D printing does have a lot of other varieties and specialties. You can 3D print with different materials, different methods, all kinds of axes. And if you want to learn a little bit more about that, I encourage you to do your own research or ask some questions because it's pretty cool stuff. But this is going to be a beginner level introduction to what 3D printing is and the process to get something 3D printed. So the first question is pretty simple. It's what is 3D printing? So there are a bunch of ways to define 3D printing. It is basically just melting a plastic filament in the shape of a digitally designed object. That's what I came up with. Probably not all encompassing, but it'll give you the basic idea that you need to get a thought of what 3D printing is. You can see some more professional definitions on the left that I just got from the internet. One important thing to note about 3D printing is that it's from the ground up, very literally. Every time you 3D print something using the methods that we're discussing, you're going to start at the very bottom of what you designed, and you're going to work your way up from there. So 3D printers start at the bottom and then print one layer at a time. So in this little image you can see here, it shows it printing a layer somewhere in the middle of a bolt that is being printed. If you imagine the bottom plate that you're printing on as your build plate, which that's typically what it's called, this is what your first layer will stick to. It's the foundation for everything that goes after that. So the 3D printer's job is to melt and deposit one layer of plastic at a time on top of that build plate. And you can see in our little image down here at the corner, the build plate is shown as having one small layer on it. After that, it's going to move up the size of one layer, and it's going to melt another layer. So you can see in this little diagram here, we've got 2 layers now. And then it's going to keep going from there. You can see it building up in this little animation. So in this, you're looking at a side view of what could be a ramp or a staircase with a small figure on top of it. So let's talk about the 3D printing process. It's basically got 3 steps. First, you start by modeling. So this is taking an idea for what it is that you want to 3D print and using CAD software. CAD stands for computer aided design. CAD software to model that thing on the computer so that you can give the computer an idea of what it is that you want to create. The second step is called slicing, not pizza slicing, not taco slicing, whatever else. It is 3D printing slicing. And we'll talk a little bit more about each one of these steps later. And then the third one, of course, is printing. It's using a 3D printer as a tool to actually create the thing that you wanted it to create. So let's go into the steps. So step 1 is called modeling. We aren't going to cover how to use 3D modeling or CAD software in this workshop, but Purple Fire Robotics is hosting other workshops in this series that will. So if you're interested in that, I highly recommend attending those. So modeling for 3D printing has one big caution, and it's overhangs. Because of the way the printer works, like you may remember, it deposits plastic layer by layer. So if there is nothing below the layer it's currently on, it's going to be depositing that plastic in air. And plastic, like anything else in the world, cannot float. So it's going to fall down and you're not going to quite get what you expected. So everything needs to be supported by something below it. You can think of it like you build the foundation of a home before you build the walls. Otherwise, the walls are going to sink down and they're not going to be where you expected them to be. So you can see here, this is the model that we were looking at earlier, the little image that I used before of, we'll call it a ramp with a small statue on top of it, or a staircase up to a figure, whatever it would be. One of the things you can note here is that it's not the highest definition. We're limited by our layer size, so you can't print anything smaller than this little space right here. But you can also see that we do have an overhang. It shows up right here. This overhang has a certain degree that it operates at, and if it is too steep, that's when you'll run into those problems. But you can have a certain amount without it being an issue. So here, that's a good thing. That's not a steep overhang. The printer can totally handle that. But if you were to do something like this, where the overhang is much steeper and you have a lot of filament, that's the plastic, that would be extruded over nothingness, so the printer would try to print over air, this would fall down and it wouldn't really come out the way that you expected it to from your model. We don't like that. Not good stuff. And remember, you guys can ask questions in the Q&A and I'll be able to see those and answer them if you are curious about anything. So one thing to remember is that if you have to print a certain model that has an overhang, there are ways to do it. 3D printing as a design method can accommodate just about anything you want. It'll just get a little trickier if you have some special requirements. So like I said, we can't print over air, but there are ways that we can print over a material that isn't part of our model, and those are called support materials. We'll learn a little bit more about that during the slicing process, but this is a picture of what a support material could look like. Here you can see a shape that was printed such that no part of it is actually touching the bottom of the build plate. And it's still able to do it because it builds these support structures. So it's never printing over air. It's always got something to grab onto, essentially. Another way to do it is to replace an overhang with a slope. So like I was saying, if you are working at this angle, the 3D printer can probably do that because there's no point where it's straight over air. It's always got something that it can grab onto. The amount that's over is just a little bit, and that's fine. The printer can deal with that. It's when you get to this angle that you run into an issue because then you don't have as much to grab onto. So one way to print things that need overhangs is to use slopes instead. So let's say you wanted to print a wall and that wall had a circle in it. So you can see here the wall is the red thing, circle punched out a hole in it. The 3D printer is going to have a little bit of an issue with this. And the reason for that is because the top of this circle is actually an overhang. You can see if it'll start at the bottom, it'll print this part, just like this. And as it works its way up, it's going to get to this gradually increasing slope. So if it prints this, it's not going to have an issue. It's going to struggle a little bit right here. But depending on the size of your hole, it could be totally unable to print this top section because it's going to be printing over air. So one way around that is to change it to a different shape like this. You can see that the slope never gets above about 45 degrees here. This 90-degree slope is going to be way too crazy for most printers, unless the hole is really small or you have a pretty good printer and you've finely tuned the settings. But if you're at that point, then this is not the workshop for you in the first place. You can also just do something like a triangle. Depends on what you need. If your goal is to create a hole for example, a dowel to fit into, then maybe you could do this because the dowel will still grip onto these edges. But if you just need a hole maybe for venting, then a triangle would be a really easy way to do it that is easy for a 3D printer to make as well. Another way to do it is to flip your object on your side. So let's say all you're doing is a wall, one single wall with some holes in it. If they need to be round for whatever reason, you can take the wall that has its holes in it, see these are where the holes are, and just flip it so that it prints with this face facing up. This way, the hole will not have anything above it, so the printer won't run into this issue where it has to print over air. This also gives you the advantage of being able to take advantage of some strength that 3D printing has. And we'll talk a little bit more about strength later, but the idea is that because it starts from the bottom and makes a solid layer, that the up and down ways, the verticality of what you're trying to create is going to be the weakest. So let's say we had a lot more strength than a 3D printer is typically able to resist. If we printed this object right here and it had those two holes in it, it would be easier for us to put one finger in each hole, or sorry, it would be harder for us to put one finger in each hole and pull to the sides than it would be for us to grab it from the top and like separate it at its layers. These layers are kind of the weak part. So you're the one designing it. You know what the thing you're designing is going to be used for. So you can figure out best how to orient it in the printer so that its strong parts are where you want them, essentially. So step 2 in the 3D printing process is called slicing. Note that we're not going to talk about how to use the slicing software because this isn't a how-to. This is just an introduction to 3D printing. You can definitely do your own research if you want to look more into this. The internet is an awesome tool, and I know because it's how I learned that it has a lot of information on how to do slicing and do it correctly. So firstly, what is slicing? It's kind of a weird word that doesn't immediately make you think about 3D printing. So here's the way that I like to explain it. 3D printers speak a different language than we do. I'm speaking English right now. Tons of people speak a bunch of other different languages. The language that 3D printers speak is called G-code. And this is essentially a series of commands that tell the printer move here, extrude this amount of filament, which just means deposit a certain amount of plastic, and other things like that. So we use a program called a slicer, and the action that it does is called slicing, to convert a 3D model that we make, that's from step 1, into the G-code so that the printer can actually understand it and know what to do, if that makes any sense. So the slicer also gives you, the person running it, the option to tell the printer how you should print the model. And it lets you fine-tune some of these settings and specifics. This is where you could say, I want extra strength in this part of the model, or I want you to print supports here, but maybe not here, that kind of thing. This is where you will have the most effect on what it's printing after the modeling stage. And a fun tip for you, a G-code file is actually a text file. So if you are bored and you want to see how the printer speaks, you can actually open it and read it. It is human legible. Obviously, it uses our alphabet. And you can, if you are really bored, write a G-code file yourself, but I wouldn't recommend it because it has, for a typical print, it could have, tens of thousands, if not hundreds of thousands of lines of G-code. So maybe don't do that, but you can. So let's talk about some vocab, right? Slicing, it has a whole bunch of words and it can get confusing quickly. So we'll do some vocab here. We got shells. Shells make me think of pasta, and they're not really that far off. If you think about it, it's the material that is deposited to form the outside of the object you're using. So this would be like its walls. Let's say we're building a house that is completely solid. We're just going to pretend this house has no living space in it at all. The shells would be the outer walls of the house. So if we were printing, I'm going to use a different object as an example, a ball, a completely round sphere, the shells would be the outer part of that sphere. All of the faces that you could touch if you were holding a ball. Anything that you can touch is part of its shell. Then we have supports. These are what I was mentioning earlier. It's something that it prints that is meant to be destroyed immediately. So it's meant to be broken off of what you're printing after you're done printing it. And then it's pretty much only used to support overhangs that wouldn't otherwise be supported. So if it's steep and you need something below it so it's not printing over air, that's when you would use a support. Then we have infill. This word doesn't make sense at first, but eventually you usually see why it is called that. It is material that's deposited inside a model to provide structural rigidity. So basically, if I printed that ball and it was completely hollow, then as soon as I picked it up, I could squash it between my fingers. And that's obviously not what we want. So it's kind of like the same thing supports do for outer overhangs, but on the inside. If we stick with the example of the ball, if there were no infill at all, then as soon as it got to the top of the ball, like we saw in that little image, it would be printing over air. So infill A makes it stronger, and B allows you to have something on the inside to keep the ceiling of your model from caving in and not printing correctly, at least. And then the last thing we have is a layer. It's something that we also talked about earlier, but it is just one level of material, and it's used as a foundation for the following levels. So you have to imagine every layer as being, integral to the following layer so that you have something to print on top of. The first layer obviously will use your build plate or your base plate, whatever you want to call it, as its foundation, because that should be a perfectly flat and smooth surface that it can build on. And then every other layer is going to use the one before it. And one of the reasons that 3D printers make products that are so useful is because the layers will actually mold to each other. Because it's so hot, it can actually, essentially weld, but not really welding, but you can think of it like that. one layer to the other so that you get a piece that at the end of it isn't like a slinky where you can pull it apart. It is actually connected on all of its layers. Even though they aren't printed at the exact same time, it's one after the other. And layers are usually measured in decimals of a millimeter. So you could say, for example, that you had 0.2 millimeter tall layers. Then we've got the three fundamentals of when you're trying to print something. How strong is it? How fast can you print it? And how much will it cost you to make it? Obviously, the cost is mostly in filament, in plastic strands that you feed to the printer to get a plastic object out of it. One unfortunate truth about 3D printing is that you're not going to get the best of all three of these unless you are paying for some expensive equipment. Your average 3D printer is going to give you good strength, good speed, or low cost, but probably not all three. Sometimes you can get two though, and it's pretty fun when you can. So you can maximize one by changing the settings when you're slicing it. Like I mentioned earlier, when you're slicing it, that's your chance to tell the printer exactly how you want to do that and how you want it to do that. So I'll give you some examples. If you decrease the shells, that's like the walls. If you say I want fewer walls and I want a lot less infill, less material on the inside where no one's going to see it. And let's say I've got some overhangs, but I'll just try to print them without supports. We'll see if it works. It'll, be a little cheaper that way. And it's right. It will be a lot cheaper and it'll also print a lot quicker. The problem is that your end object, once it's done, if it's in the right shape and none of your overhang has failed, then it's going to break pretty easily. If somebody grabbed it and squished it between their hands, it would be gone. So the other way to do it, oh, yeah, this is good for prototyping. If you're initially doing something and you're not sure whether or not it's going to work, this is a great way to print it, is to have low shells, low infill, and basically just have it set up so that you can see the shape of it, but it's not strong enough to actually do what you've designed it for yet. A lot of 3D printing allows for iteration and things like that. So prototyping is a great way to do it. And in that case, you don't need it to be strong and you want it to be cheap. And it doesn't matter if it's going to break because it's not your final product. So by doing the opposite, let's say we print it with 5 walls. It's going to be really thick walls and it's going to have tons of infill on it. So it's got a lot of material in it. Maybe 20 or 30% of that airspace is filled with plastic now. Your print at the end of it is going to be super strong. If you try to squish it, you're going to feel a lot of resistance. Depending on how strong you are, you can probably do it, but still you'll meet a lot more resistance. The problem, the trade-off here, is that your print's going to take a long time. It's going to take maybe 8, 10, 24, 30 hours to print. Printing is not particularly fast. And it'll cost a lot more because you'll be using more filament. As you make the walls thicker, you're using more plastic to make each wall. And by filling more of the model with plastic, you're going to be expending it in that way too. And this is great for your final products. So after you've iterated, after you've designed your thing and printed some prototypes that were weak, just cheap to see if it worked even remotely the way you thought it would, and you've got your design down to an end design, that's when you really want to do these final product prints. So you'll say, okay, I've got it. Now make it strong. It'll cost a little bit extra, but I want it to work. I want it to be resilient, and I want it to last for the application that you've designed your 3D print for. So that would be a really good use case for that. And one cool thing about most slicing programs is that they'll give you an estimate of all of these values. My favorite program is Cura. They unfortunately did not pay me to say that, but alas, my favorite program is Cura. And it will actually tell you the speed. It'll tell you exactly how long it'll take to make it. An estimate, it is, but it's still better than nothing. Usually if it tells me 8 hours, it's going to be around 8 hours. It's not going to be done in 1, and it's not going to take 15. And it'll also tell me the exact cost. So I'll tell it how much I paid for the filament that I'm going to use and how much filament I got, and it'll do all the math and figure out, okay, so to print this ball, it's going to cost you 38 cents. Or to print this house model, it'll cost you $1.12. And it's a pretty good estimate of how much filament it's going to use. And the last step, which is the easiest step, is printing. All that needs to happen is the printer heats up, it melts the plastic in the right shape, like we were seeing in that picture from earlier. It's got to melt that plastic, and it's following the model that you did using the settings that you sliced. And then once it's done, that's it. You pretty much got a completed object. So as a recap, we've got modeling, where you have to design your print carefully to make sure there aren't overhangs in the wrong place, or that you are planning ahead to support those overhangs with supports. You're designing your object, and you're going to have it be printable, and it'll be useful to solve some problem that you have. This can be big problems like the air intake on my car is broken, so I'm printing a replacement part for it. Or it could be little things like I want somewhere to store my pencils. 3D printing's applications are practically infinite. Anything that you can think of, you can probably print something to help with. Your limits, of course, because 3D printing uses heat as a method of printing it, is it's hard to 3D print things for hot applications. So if you are trying to do something to go in an oven, maybe that's not something you want to 3D print. You want to machine that out of a metal component or something. And then after step 1, modeling, you go into slicing. So you're going to tell it how thick do you want the walls to be? How much plastic do you want inside it to keep your print strong and make it able to support itself? All these settings are going to be really important to how your end result comes out and the way that the printer gets there. Does it get there by using tons of plastic and taking forever? Does it get there by using no plastic and being done quickly but giving you maybe a more weak print, which could be great for prototyping? As you can see, there are tons of options and you never are limited much by 3D printers. As you get more into it, you can of course buy more equipment and buy nicer filament that maybe has different restrictions on how hot it can get, the ways that you can print it. Some filament does overhangs better than others, so if you want to do an overhang that's a little bit steeper, maybe get a different filament or a different fan for your printer or a different printer, all kinds of things that you can change to get the end result that you want for your project. And that's it. I hope that you guys enjoyed it. If you have any questions, you can always ask in the Q&A, or you can reach out to me. You have my email. You can reach me on the university directory, or you can learn more on the internet. It's got a lot of resources. If you're interested and I didn't talk about something or you want more information, give it a Google. A lot of 3D printing is done by hobbyists, so there's going to be a lot of information online for how to get started from the beginner level all the way up to you want to make a complicated, multi-part, watertight 3D printed object. You know, these are all things that you could do, and you could learn how to do it yourself. Well, yeah, thank you guys for coming. I hope you check out some of our other workshop series that we've got going on later this month. We have a lineup of 10 other workshops, and it should be pretty cool stuff. So thank you.